Hi guys, so I've noticed that a lot of times students have trouble deciding if a final answer should be positive or negative. So let's do an example of just that. So here the goal is to find the cosine of half of theta, but we don't know what half of theta is. If it said cosine of theta, we could use SOHCAHTOA, but this is theta over 2. We're not ready for that. So we go to our trig identities. That will help us. So if you look at your cheat sheet or your trig identities sheet, it'll say that cosine of theta over 2 is equal to plus or minus the square root 1 plus cosine theta, I believe it says, all over 2. So let's find cosine of theta first. Perhaps we need a picture. So if I were to draw the x and y axis, the primary locations, 0, 90, 180, and 270. And of course, this could also be viewed as 360. Okay? Our given angle theta is bounded by these numbers, but I don't see these here. So we can go coterminal. If I subtract 360 from this and from this, I'd get back, was it 180? Less than or equal to theta, less than 270, it looks like. So those numbers are recognized. It's between here and here. So my triangle, my reference angle theta, is in a triangle in quadrant 3. And I have some information pertaining to theta. We know that the tangent of theta is this over that. Tangent is SOHCAHTOA. Tangent is opposite over adjacent. So this is your opposite side, and this is your adjacent side. So from this position theta, your opposite is square root of 7, and your adjacent is 2. But always be mindful of where you are. This is in quadrant 3, so you're moving to the left, and then you're moving down. For that reason, these are both negative. Okay? You can go Pythagorean theorem if you'd like, and you should, to find the hypotenuse. That would be, it looks like it would be the square root of 11. I will save us that algebra. Okay, Pythagorean theorem. The hypotenuse is always positive. I don't care which quadrant you are in. Now from there, let's go back to the main problem. I want the cosine of theta. Well, as a quick FYI, the cosine of theta, as a quick calculation, cosine is adjacent over hypotenuse. So adjacent would be this. Hypotenuse would be that, so that's negative 2 square root of 11. And if you were to rationalize this, that would be negative 2 square root of 11 over 11. Okay? So this is the value of cosine theta, which can get replaced in right there. So let me continue my work way over here. So we have plus or minus the square root, plus or minus the square root. We have 1 plus cosine theta is negative 2 square root 11 over 11, all over 2. Okay. Let me just quickly run through this algebra so that we can decide whether it's positive or negative. So the algebra should give us back this conclusion here. But now, the gist of the matter, the heart of the matter, I should say, is it positive or is it negative? Well, we understand that theta is in quadrant 3, but this is this, is this, is this, is this, is this, is this, is that. The original expression is not located at theta. It is located at half of theta, theta over 2. So if theta is in quadrant 3, where is theta over 2 in? What quadrant would that be in? So what I would have you to do is to go back to the original inequality that contains theta. Do not use the modified coterminal version of it. The purpose of this was to make clear where theta was. But now the discussion is theta over 2. And to find theta over 2, you go to the original inequality. And in this case, divide each of these by 2. Divide by 2, divide by 2, divide by 2. If I divide this by 2, I would get back 270. If I were to divide that by 2, it'd be theta over 2. Divide by 2, that would be 315. So this tells us that theta over 2 is between 270 and somewhere in 315. So it's safely tucked in. Theta over 2 is safely located somewhere in quadrant 4. And in quadrant 4, this is in quadrant 4. In quadrant 4, cosine is positive because cosine is affiliated with the x-coordinate. And in quadrant 4, your x-coordinates are positive because you move to the right. So this entire expression should be positive. So down here, this result is positive. And because it's positive, it is not necessary to emphasize the addition symbol or the positive symbol. So always go back to the original inequality that has theta to decide where theta over 2 is located.